All right, we're ready for section 12.2. Now this is collecting data, which is called sampling. Now in this lesson, there's really just a lot of reading. Not a lot, but it's just mostly reading is where you're going to get most of your information. So let's just go ahead and read, and then I'll help you a little bit with this and that on your worksheet. I don't think I'm going to grade the worksheet today. I probably won't grade a lot in this chapter. Probably just wait till the quiz. So anyway, let's look at collecting data. So that sounds simple enough, but it can be a complicated process. After all, we want to make sure we collect the right data. The data we need in order to come to an accurate conclusion. But in the previous lesson, we looked at the concrete data, the ages of all the students in a specific class. But what if we wanted to find out in general what ages attended sewing classes across the United States? Unless we had a way of collecting data on every single sewing class in the U.S., we'd be forced to look at the ages of just some sewing class attendees and draw conclusions based on them. Now, this gray box is very important. Now, here's some terms. A sample is the portion of a population selected for analysis. That's your definition of a sample. In other words, a subset. Remember from last chapter? A subset of the whole population. In our example, the sewing attendees whose ages we look at would be our sample. Now, by population, we mean the whole group or set. We're considering, in this case, every single sewing class attendee in the USA. Okay? So your population in this is, all of the people that go to sewing classes. Your sample are going to be, all of those that are in the United States. So, that are in every single sewing class. Yes, I'm getting confused. Now, let's look at underneath here. Much of the data you'll encounter in the news and other outlets is based on sampling, taking a sample of a population. So it's an important concept to understand. So let's think through some of the challenges and dangers in basing decisions off of a sample. In order for the data to have a meaning, the people in our sample would have to represent the whole accurately, and we'd have to interview enough people to have a reasonable picture of that whole. Now, there's some examples here, but I was going to tell you, the other day I was listening to the radio and I heard of a poll that had been done, and this poll favored something, and it's political, so I'm not going to get into it, but it favored something that didn't seem right. From all of the other information I'm getting, it didn't seem correct. Well, come to find out, when someone did some research on that poll, the population of people that had been sampled were almost all, a huge percentage, were of a particular political group. And therefore, the answer that they got to the poll, their data, their stats that they got from the poll, went in their favor. So you see what I'm saying? They interviewed people from a particular, group, so that their answers would be what they wanted them to be, which is terribly wrong. So in our sewing class scenario, if we based a conclusion about ages that attend sewing classes off a sample of just one or two classes, we might end up making a very wrong conclusion. What if those classes were structured to appeal to young girls? Or what if the surrounding area was a retirement community with lots of older women? For another example, if one section of a congressman's district has voters of a significantly different income, different religious belief, or different top job, taking a sample of that section wouldn't be representative of the whole district. We need to make sure that the sample that we use is a random selection that will thus represent the whole population we're trying to find, such as all the different types of sewing classes or voters in the district, and that our sample is large enough to really give us a picture of the whole. We couldn't survey just 5 people and expect the results to tell us the ages of all the sewing class attendees in the United States or what all the voters in the district thought. So when you see a survey result listed or a stat quoted, look at how the information was collected. Was it based on random selection? It's also a good idea to look for what are called the margin of error, the MOE. and the confidence level. Let's explore these two numbers using an actual example. Before the 2012 presidential elections, Gallup, which is a polling company, released a report titled Romney 49%, Obama 48% in Gallup's final election survey. The fine print at the bottom explained that one can say with 95% confidence that the maximum margin of error is plus or minus 2 percentage points. What exactly does that mean? The margin of error of plus or minus 2 percentage points means that the results listed, the 49 and the 48%, might vary from total population by 2% either direction. In other words, the percent of the whole population in favor of Romney could range from 47 to 51, while the percent in favor of Obama could have ranged from 46 to 50. This means that more people in the population as a whole could have actually favored Obama. Statistically, since only a sample was interviewed, we can only expect the results to reflect the whole within a certain percent, calculated here to be within 2%. Up to a certain point, after which increasing the size doesn't really change the results, the larger the sample, the smaller the margin of error will be. The confidence level of 95% means that the survey has a 95% chance of being accurate within the 2% margin of error listed, and a 5% chance of being off by greater than the 2% error listed. In other words, we're 95% sure of the results accurately reflect the whole population within 2% either direction. But there's a chance that if we tested the whole population instead of a sample, our results would vary by more than 2%. So with results of 49 and 48%, a 2% margin of error, and a 95% confidence level, all we could conclude is that the race is close. The survey didn't show who was in the lead. Plus, it's important to remember that even if the results were more decisive, pre-election polls do not necessarily tie with what will happen in the voter box. So a lot goes into collecting stats. Wait till we look at organizing them. Now, while you may never need to sample a population in your lifetime, understanding the sampling process can help you discern through the many stats you'll encounter in life and know if the interpretations offered are reasonable. Remember to look at the process used. Was it random, the margin of error, and the confidence level? Those are the three things we've got to look at. All right, so let's look at your work text, 12.2. It's front and back, but on the back there's some skill sharpening at the bottom, percentage off, 5A and B. You're going to be reading that to see if they're accurate stats. The back of the page should be pretty easy. Just want to make sure you understand the front right here. So look at number 1, taking a sample. Let's say that you want to find out the opinion of people in your whole neighborhood about a proposed addition of a lot. Suppose you conduct a random survey of a sufficient portion of the people in the neighborhood. In this situation, which of the following constitutes what we would call the population? So, remember when we were talking about population, wherever that was on the first part of the page, we were talking about population. So according to that, which one of those things on part A would constitute the population? Everyone living in the neighborhood would constitute the population. Wouldn't be good if you just did whoever's in favor of the lot, because then your answer is going to be yes. You set your answer for yourself. Okay, and on B, which of the following constitutes what we would call the sample? Those who returned a survey would be your sample. Those are the ones that you sent a sample to, and then they sent it back to you. Okay, so that's your population, and then that's your sample. Now, understanding sampling, list 2 things we need to make sure a sample is. A sample needs to be random. This is on the bottom of page 230, the very last paragraph. it needs to be random, and it needs to be large enough. Okay? All right, look at number 3. Margin of error. For each of these stats, listing the results of hypothetical surveys, look at the margin of error, the MOE, and list the range the results really showed. Here's an example. One candidate has the lead in the polls, with 51% of people surveyed saying they are planning to vote for him. Okay, the margin of error is 5%. So your range then is 46 to 56% because it's up or down 5%. See how that goes? Okay, so I'm not going to help you with A, B, and C. You're just going up or down however many it says. So anyway, all right, and then I think you should answer number 4 yourself, and the back should be fairly easy. If you need help, let me know, but I think the rest of this should be a pretty simple worksheet for you, okay? That's